Okay, so in this problem we got a 0.12 kilo block that is held in place against the spring by a force that is horizontal and is 35 newtons, and this force is external. When this force is removed and the block is projected with a velocity 1.2 meters upon separation from the spring, the block will descend a ramp that will have a velocity 2 being equal to 1.4 meters per second at the bottom. Then it also says that the track is frictionless between the points A and B, and that the track is frictionless between point A and B means that the block will enter a rough section at B that will extend all the way to the right to E. The coefficient of the kinetic friction is also 0.26, and the velocity 3 is going to be equal to 1.4 meters per second at point C. Then it also says the block moves on to D, where it stops, no velocity anymore. So they're asking us to find the initial compression of the spring in centimeters in this problem. Okay, so we just write down all the information we have right here and then we draw a little picture. So they're also giving us that F is going to be equal kx, that's going to be 35, but we don't know the value of k or x, so we just drew a representation of what's saying on the question, and then we have the following. We have that mechanical energy of point A is going to be equal to the mechanical energy of B. So we could also rewrite that as 1/2 kx squared being equal to 1/2 mv1 squared. Then we end up with kx squared being mv squared or mv1 squared. So we can rewrite x being equal to 35 over k, so we can solve for k. So we'd say k squared being equal to 0.12 times 1.2 squared. That's going to represent the mass times the velocity squared. So k squared is going to be 0.17. So we just replace the x that is right here with the value on the left. So we got k times 35 over k parentheses squared is going to be equal to 0.17. So as we continue doing the algebra, we can cancel out the k's, and we end up with the following. We end up with 7,205.9 for the value of k. So to find x, which is what we're asking in this question, we just have to multiply k times x being equal to 35. So x is going to be 35 divided by 7,205.9. And that's going to be 0.00485 meters. But the question is asking us to find the initial compression of the spring in centimeters. So we just convert it to 4.9 centimeters. So in this problem we got a spring with a spring constant of 22 newtons per meters. Then it says it's a stretch from equilibrium to 2.9 meters. So the question is, how much work is done in the process? Okay, so we got a few things going on. We have the k is equal to 22 newtons per meter, and the distance we represent as x being equal to 2.9. We also know that when we stretch the spring, there's two forces, one opposite that's going to the left and one that is going to the right, so we can stretch the spring. Of course, the force that's going to the right is going to be much bigger than compared to the opposite force is going to the left. Another information is that this is going to be a constant velocity. So we represent the force as negative kx. In this case, F is going to be u. But what is u? U, or in this case delta u, negative delta u, is going to be the work of the spring. But we need to find the work of the force that is stretching. the spring. So it's going to be positive delta U. Now the work, the formula comes from the work being the F times the displacement. And F we can represent it as Kx, as we saw up here. And then we just multiply by delta x. So we can get x times kx divided by 2 being equals 1/2 kx squared, which is the formula that we're going to use. One other thing before we proceed solving the problem is that the x is going to represent, let me show you, the x right here is going to represent the base of the graph that is right here. So the work is going to be the area of this curve. Kx is going to be this arrow right here represented, and the displacement is just pretty much the base. So we could say that the work is equal to the base times the force divided by 2. So that's how we got the x that represents the base, the force being kx, and we just divide it by 2. Now, as we just plug in the values, we can say 1/2 times 22, which is the force, times 2.9 squared is going to give us around 92.51 joules. So that's how we say that our answer is going to be 93 joules. Letter A.